Yeah, it wasn't sending, so okay. All right. Highlighter, pencil, maybe one other color or two. I would recommend two different colors. Maybe not necessarily for every lesson, but for the first, like throughout this chapter, I kind of switch it up a little bit with colors just to emphasize certain parts. Again, you don't have to, but I think it would be beneficial to do so. Especially because down the road, you when you come back to review, you don't necessarily remember everything, right? Because it all just looks like a big, like everything happened at the same time, right? You kind of want to highlight what was inserted or the important portions of it. Okay. 7.1 systems of linear equations. We can use equations to model a situation or scenario. Okay. And so that's what we're going to do here. And we kind of go the same way as before. If the variables have not been defined or introduced, then we do so before we come up with our equations. Okay, so example 1. A stage is rectangular. Its perimeter is 158 feet. The width of the stage is 31 feet less than the length. Okay, the width of the stage is 31 feet less than the length. Okay, and so what we have here is a stage, right? So for A, we're going to create a linear system, right? A system that just means more than one equation. Okay, a system is just more than one equation. That's all that is. So create a system so you know there's going to be more than one equation that models a situation. So let's start with the facts. If this is the stage, it's rectangular, we know that, and there would be a length and a width, right? And we know that this is our stage, and so we will let you can use X, you can use Y, it's up to you. I'm going to use L, stands for length in feet, and width W stands for width, also in feet. Okay. Now, you can start with what is already known, right? And that is that the perimeter, the first equation would be that the perimeter is going to be 2 times length plus 2 times the width, right? To find the distance around, it's 2L plus 2W. Okay, so you come up with that, and what do we know about in this scenario, in this equation? They give you something that you already know, and that is that the perimeter itself is 158 feet. So when you have this, when you start with an equation, plug in what you know, right? Because you want to try to have only so many unknowns, right? So that's that. Our second equation is given to us actually by the question. The width of the stage is 35 feet less than the length. So you can read that question, say, hey, the width of the stage is length minus 31, right? Because the width is 31 feet less than the length, right? So that's your second equation there. So you have now effectively come up with two things that are true. Both of these are true, right? You know that the perimeter, the relationship between the sides and the perimeter is given here. That was just a fact, right? We all know perimeter of a rectangle is this. We substituted what we knew, so we have that equation. And we also were given this by the problem itself. So here is your system. Okay, so we can call this, I'm going to clean this up. This is technically already our system, but we have our system of equations. Just for to save some time here, I just do EQN or EQNS, right? Just to save ourselves some space. And so let's transfer it over. We have 158 is equal to 2L plus 2W, and that W is L minus 31. So these are happening at the same time, okay? So both of them have to be true, right? For this scenario to be correct, right? For us to be right, we have to make sure both of the equations are followed, okay? Both of these restrictions, so to speak, okay? So this is A. All of this is answers A. Does it always have to be that long? Probably not, but I'm showing you how I got there, right? And so basically, you can say that from this we got that. From the fact that we were, so sometimes you have to think outside the box, right? Rectangle, yeah, I know what perimeter is. I know what the equation is for perimeter. It doesn't need to be given to me. And then this highlighted part here, I'm going to go arrow up, over, down. It's almost like Pac-Man, right? There. I don't even know if youth these days still play Pac-Man. But anyways, right? You go there, and so both equations were deducted from the problem. I know I'm talking a lot, but I want to make sure I introduce this concept properly. Now it says B, verify that the stage is 55 feet long and 24 feet wide. Okay, so I'm going to make an arrow go up here and just define verify. What does that mean? Right? A solution to a system. So write that down, right? When we verify, we have to have a solution to a system is a pair of values that satisfy both original equations. So this is something that I would like make a cloud out of, right? So that's going to be important to us. We're going to verify that this is in fact a solution to this system, but we need to verify and we need to plug those values in and make sure it works for both, right? So right now, go back to length and width, right? Those are our variables. It's kind of like X and Y, right? So length is 55 and width is 24. That's what we were told, that this combination of 55, that point that is 55, 24, is in fact going to be the solution to this system. So we do a left-hand side, right-hand side kind of check for both, okay? So I'm going to make a little box here just to give myself room, okay? So left-hand side, and then you have right-hand side. And so basically, the left-hand side, we take one equation at a time. So the left-hand side of this equation is 158. You can actually make a T chart out of it. And the right-hand side is 2L plus 2W. Okay? And then you keep working at it. Nothing can be done with the left, but on the right side, you can plug in what you're given. So 2 times 55 plus 2 times 24. And that gives you 110 plus 48. Okay, 110 plus 48. and that adds up to 158. So you've done some work on this side, and now you know that left-hand side is equal to right-hand side. So left-hand side is equal to right-hand side. That's what you're checking for. And so it definitely is a solution to the first equation, okay? And then we do the same thing, left-hand side, right-hand side for the other equation. So you take this equation here, the left-hand side would be W, right-hand side would be L minus 31. And W is given to us by that it is 24, length is 55, so you go 55 minus 31, and that equals to 24, right? And then you realize that, and I'm going to erase some of this line because I don't need all of it. Left-hand side is equal to right-hand side. That's what you want. If it's not, then it would cease to be the solution to the system. Okay? Therefore, okay, sorry, I'm going to run out of room here. Therefore, L is 55 feet and W is 24 feet is a solution to the system. Because it satisfies both equations. If there had been 3, you would have had to plug in and check all 3 equations to make sure it works out. That's what verifies means. That's what checking means. Okay, you check whether or not the left-hand side is equal to the right-hand side. And then, so if it's the case for both, you are correct. That is a solution to the problem. Okay. Okay. I'm going to wait for a little bit for you to catch up there. And then we'll try it one more time. Except for I will give a lot less notes, right? Fewer notes on that one. And I also didn't specify, this is basically B here, folks. Like this, doing the charts, that is B, part B, that's what we're doing here. And A was just setting up our system. Okay. So as you can tell, in this case, it wasn't necessarily slope intercept form or general form. We're gonna tend to not specify what form. You basically just read and interpret and write it out the way it's basically stated and the way it makes most sense based on the context. Okay. Next, a school raised $140 by collecting 2,000 cans and bottles for recycling. The school received 5 cents for a can and 10 cents for a bottle. Create a linear system. Okay. So we're going to start off with A by defining. Okay. We can let X be equal to the number of cans and Y be equal to the number of bottles. Okay, so that would be your introduction to the variables. And you have to be careful here. School raised $140 by collecting 2,000 cans and bottles. Okay, and that the school received 5 cents per can and 10 cents per bottle. So how would you come up with your inequality here? Well, this This one deals with the number of items, right? Like how many items do you have in total? And this one deals with the amount, right? Amount raised. So they're in the same sentence, so it's harder to deduct your equation, right? But really what you would have to do is you would have to say, okay, if X and Y represent the number of bottles and cans, then one of my equations would have to say this, that the number of cans and the number of bottles, right, is equal to 2,000. Okay? And I'll make an arrow going out and over, right? This is telling us, this equation right here is telling us that the number of cans and bottles are 2,000. That's all we know. Okay? And then we have another one, which is this one here, that we raised $140, and we're also told how much we get for every can and for every bottle. Okay? So basically 5 cents in dollars would be 0.05. So you got 5 cents for every can, and you got 10 cents, right, for every bottle, and whatever combination you get, you know you got $140 for it. So the dollar amount associated with each of the variables, right, those are the coefficients we use, and we associate that with 140. Okay, so for now, usually we don't put the units down, but why don't we do this, right? Dollar amount, dollar amount, dollar amount, right? So we know, right, that we used the dollar amount and we equated it to the dollar amount given, which was 140. Okay, and so we go from here. Maybe I'll use a different color. Okay, I'm going to use over and make that. And basically, maybe we got to underline this and intersect that line, right? We use those two to come up with our second equation. So our system here, we usually do this, okay? We have x plus y is equal to 2,000, and 0.05x plus 0.10y is equal to 140. This is the system. So these two things are happening, right? They're both happening at the same time, right? You have the number of items and also how much money you made, okay? They could have added a third one, right? Like, let's just put it into perspective. If they said, if this continued and said that a can holds 355, I think it's 355 mLs for a can, right? And a bottle holds 500 mLs, and they collected a combined volume of, let's say, 20 liters, right? Then, oh, okay, there's a coefficient for the amount that we're getting for can and per bottle and how much we collected in total in terms of volume, right? They could have done that. So then those would have been the coefficients, the numbers that went in front of your variables, right? You say, okay, mLs go with mLs, right? Dollars go with dollars, and so forth. So you gotta just keep that in mind. And now, so this is A, we're done A. We're gonna block this off and say, hey, is 1200 and 800 a solution? Okay, so basically we do the left hand side, right hand side for both. I'm gonna use this one here. I know that it's 1200 plus 800 on this side, and on the right hand side there's the 2000, right, of this equation, and then this is 2000. So left-hand side is equal to right-hand side. You could have written out the actual equation first, like x plus y on the left and 2000 on the right, but I don't really need that. It's fine just to leave it like that. 1 second here. All right, let's keep going. Left-hand side, right-hand side of the other equation of this one. So you got to give yourself a bit more room, 0.05 times 1200. I'm going to run out of room, so I'm going to back up a bit. So I'm going to block this off here. It's going to be 0.05 times 1200 plus 0.10. Oh boy. 0.10 times 800. And I'm just going to have to shift my chart a bit. Maybe it's right hand side is here, which is supposed to be 140. So I plugged in the 1200 and 800 into x and y here and wrote it down, and you get 60 plus 80, and that is 140. So left hand side is equal to right hand side. Therefore, x is equaling to 1200 and y equaling 800 is a solution to the system. They satisfy both equations. Sorry about the mess there. And I think example 3 we're gonna leave. It's basically the same as example 2, it's just a little different, but really the same steps, right? So we're gonna leave that. I think we've got enough with these two examples here. The homework for this part, homework for 7.1. Let me just pause this here. We'll go get page 405, 6, and 8, just for 7.1 for this type of scenario, right, where you model that.